Awesome. So thank you for taking time to come to listen to our session. I am Kareem. I am a product manager with Amazon Web Services, and I lead the governance aspect of it for HyperPod clusters. And today I will be talking to you guys about a recent launch that we did. In fact, it was announced in Swami's keynote yesterday, HyperPod Task Governance. So anytime, if you're not able to hear me, just raise your hand. I'll try to be a little bit more loud. So what happened last year was there was this big advent of Gen AI, and most of the companies started to use train foundation models, and what they were seeing is all of their models were growing 4 to 5 times a year and doubling every 6 months. At the same time, their data set sizes also was doubling every 8 months, but that also impacted their time to market and the costs. As you can see, it was constantly increasing, and with all these things taking time, there were these main challenges that our customers were facing. The first challenge was with data collection. What that means is that in order to train your model or build a large-scale Gen AI model, you first need to get data. It's easy said than done. You need to get a vast variety of data, large amount of data, make it clean, prep it better, and keep it ready. Once that is done, then you have to be able to provision and create your clusters and manage the availability of those clusters so that your data scientists can run their training models on it. And as that is going, you have to also make sure that your infrastructure is stable. Now, just imagine that your data scientist is doing all of this stuff, and then suddenly the cluster dies. That is just not where you want to be. And in order for you to also accelerate your training, you had to come up with various complicated strategies for enabling distributed training. So what Amazon SageMaker did was, this was last year that we came up with SageMaker HyperPod. What is it? It is a HyperPod. HyperPod is a set of clusters that enable a resilient environment. What that means is they self-heal whenever one particular node or a cluster goes down. It enables you to do your distributed training much easier so that you don't have to do the heavy lifting. And it gives you the control over how you are submitting your tasks and workloads so that you have some sort of more control on your resource utilization. All of this enabled our customers to reduce their training time by up to 40%. So this was all good, amazing, right? We saw a problem, we launched SageMaker HyperPod, and we got the training time reduced by up to 40%. And we got a great adoption across our customer base. As you can see, we have some well-known names and some startups that were using HyperPod. And this year September, we also launched Amazon Elastic Kubernetes Service support for SageMaker HyperPod. What it does is it enables you to create the HyperPod clusters on EKS. But why, right? So that you could also extend your resiliency all the way where you can make your clusters and jobs more resilient. They can start from where they actually stopped, and your clusters could be repaired on the moment, at the spur of the moment, and that's why we launched this. So, as you can see, we saw an issue with time it takes to train models, so we launched HyperPod. Then we also launched HyperPod on EKS, in order for customers to be able to have a very resilient environment. But then customers came back to us, and customers said, I have these issues. The first issue is that today, when I get a HyperPod cluster that is running on EKS, I have static allocations that I need to do for my teams. What does that mean? As you guys may have experienced, your teams, your data scientist teams, your organizations have budgets. And you have to have, per that budget, allocate this costly, scarce compute to these teams. And these are static allocations. A team of data scientists running a chatbot gets so many P5s, a team of some running some other model gets so many P4s, but that leads to under and over allocation because it's static. You cannot easily move the compute across teams. What does that lead to? That leads to your compute being idle more often than not. That affects your tasks that are waiting. If you have a team that has a lot of tasks that they have to get executed, but they don't have access to idle compute sitting in other teams' allocation, then you have just increased your waiting tasks, and you cannot also automatically prioritize your tasks as your data scientist. You have to go stop a task, then start a high priority task. And as an admin, you have no visibility of how the utilization of your clusters are. There is no way to get a real-time information. What does that lead to? That leads to low utilization of your compute. And this is not just any compute. This is your accelerated compute, which is scarce and costly. Your organization has already invested a lot of money on this, has done the budget allocation, has allocated compute to the teams, but the teams are not able to get the maximum out of it. Data scientist productivity is reduced. Why is it reduced? Because the data scientists who have tasks waiting cannot actually use the idle compute that is available, but there is compute available. So they have to wait. They have to go through some organizational bureaucracies or have to move nodes from one team to another, only to let go of it when the other team whose nodes it is come back. And what happens? You have increased costs. Why are the costs increased? Organizations have to go and invest and get more of this compute so that the teams don't suffer. Very interestingly, Amazon Retail and Amazon AI teams also had the same issue. And I would like to bring my friend Joy from Amazon AI teams to actually talk about the exact issues they faced and how they brought about some innovation there.
Thank you, Kareem. Hi, everyone. My name is Joy. I lead the central efficiency team from Amazon. So I'm here to talk about the Gen AI challenges and innovation story. So like many of our customers and partners, Amazon has been increasing our investment in Gen AI, and we expect that trend to continue in 2025 and beyond. With those new increased investments, the first challenge that we see was many teams and projects have high demands for the accelerated compute resources, which is key for AI development, but we have low supply to allocate to them. And further, the static allocation Kareem just talked about is not working well because there will be some teams have allocation but have idle capacity. At the same time, the teams that's waiting for allocation have nothing to use. So from a utilization perspective, there's a lot of inefficiencies there. And on top of all that, teams don't really track utilization metrics. So if we go to scientists and teams, they don't even know how well or how bad they are doing from a utilization perspective. And there's not a really standardized way to monitor the utilization for leaders or scientists and teams. So how do we address these challenges for allocation and maximizing utilization? We built an internal service to do AI orchestration and allocation for our internal teams. What we did was to pull all the accelerated compute resources together, and with our purpose-built dynamic scheduling algorithm, we can maximize utilization across all projects and teams. We also try to help our customers with a good experience. We provide notifications to scientists and customers so they know when their job status changes. For example, if your job gets started, you'll get a notification. If your job gets stopped, you'll get a notification. And we would also provide central utilization metrics to customers and leaders from both instance usage hours perspective as well as cluster utilization, including core and memory and power draw metrics. And we also work to add features for resiliency. We would do regular health checks on nodes, ensure there's not a failure node when teams are submitting jobs, as well as automatic resubmission of jobs when there's a failure node submitted, and restart the job automatically from their last checkpoint. So via this whole comprehensive system, by leveraging idle capacity, we're able to achieve 90% plus utilization across Amazon teams. This has helped address the challenges we just talked about, where demand is high, low supply, and low utilization. So team now not only meet their accelerated compute resources demand, but they are also able to accelerate their development at times. So overall, we smooth out the demand across Amazon and be more efficient. With that, I'm going to hand it back to Kareem.
Thank you, Joy. So as you saw that Amazon also went through the same evolution, same phases of how low utilization was affecting Amazon, and Joy and her team came up with this amazing innovation. And as it happens that we also wanted to bring this innovation to our customers. So with that, we announced the launch of SageMaker HyperPod Task Governance. So SageMaker HyperPod Task Governance enables you to maximize the utilization of your accelerators, at the same time reducing the costs for all type of your workloads or tasks. It could be for model training, fine tuning, or inference. What are some key takeaways from this? And I will be diving deep into those key takeaways in the upcoming slides, but what are at the very high level? First is you can do dynamic allocation of your compute or your compute resources across your teams, still maintaining the budgets. Second is you can ensure that if there are tasks waiting for compute resources and there is a contention of these compute resources, high priority tasks get prioritized before the low priority task, thereby increasing the right value of your compute. You get real-time monitoring and audit of your compute resources as an admin to see not only how the health of your cluster, but also the governance of your cluster. What does that mean? Governance of your cluster means that how is the allocations doing with respect to the teams? Are teams overusing? Are teams underusing? Is there a lot of bursting into idle compute happening? Are there a lot of tasks waiting? And this real-time information will give admin the capability to turn the knobs so that they still keep continuing the utilization of the compute high, but at the same time making sure that the teams get the value. And all of this increases the utilization of your compute resources, and at the same time reducing the cost by up to 40%. So what is it? So what I'm going to do in our next upcoming slides is I'm going to actually talk to you about what it does, how it does, and walk you through a demo. So what it is it's a smart scheduler and orchestrator that enables dynamic allocation of compute resources. What does that mean? What does dynamic allocation of compute resources mean? In the prior life, there was static allocation. So if there was a team of ML engineers working on some model, they were given a static allocation of, 10 P5s or 20 P5s, which was with them. They couldn't go beyond unless they had to go through the allocation process again, which was a manual process. But with dynamic allocation, you are given a quota of 10 P5s or 20 P5s, and you are guaranteed compute per that quota from your shared cluster. If you need to use over quota, you are allowed to use over quota at this, with the spur of the moment. You don't have to go through the manual process again. That's your dynamic allocation. Second is task governance enables you to utilize the idle compute. So if you have compute sitting idle that has not been allocated or has been allocated to a team but not been utilized, then other teams can burst into that idle compute and utilize that idle compute. Because of that, the team's wait times reduce. They don't have to go hunt around the compute to submit the tasks that they have there in their queue. They submit and task governance takes over it and makes sure that whether it goes to their guaranteed compute or whether it goes to an idle compute, whichever helps accelerate the job submission. And there is also the real-time task prioritization. If there is resource contention with tasks waiting in queue, then what happens is, based on the prioritization that has been assigned to the task at the time of submission, task governance kicks in and makes sure that high priority tasks get the compute they need before the low priority task can be submitted. And if there is a low priority task running, it will be preempted to make sure that the high priority task gets those compute resources. And you will get a real-time observability. And we'll actually see those dashboards as we do the demo. So with task governance, you have increased the utilization of your compute. And you have reduced your costs because now you don't have to go hunt for compute for your teams that are waiting because they can now use the already available compute that is sitting idle. And you accelerate the time to your market. So what are some common use cases that we have unlocked for our customers? The first one is resource management. And this is actually very critical and the first step of any resource allocation or management that happens in an organization where budgets are set, teams are given so much quota. So you just do this one time of resource management for this team per their budget. And the teams are all set. They don't have to go hunt around for extra quotas or anything. Dynamic allocation, what does that mean? It means that when a team needs more than what they have been allocated, they will be able to burst into compute that is sitting idle. So you will be able to dynamically use the compute that was not allocated to you but available for you. Task orchestration is every team will be able to submit tasks. They will be guaranteed compute per their quotas. But if they have maxed their quota, then task governance will automatically do preemptions and prioritizations so that the data scientists don't have to sit and do this. Real-time monitoring, you not only get to monitor the cluster's health, you get to monitor team's health. What does that mean? How much of the allocation has the team been given? How much are they utilizing? Do they have waiting tasks? Do they have long-running tasks? Or is there one particular team that is being a culprit of getting a lot of allocation and never using that compute, and so that they can do any adjustments? Or is there a team that is always starved and they always need to burst into idle compute? And cost optimization. So all of these inputs enable the admin to make sure that the cluster costs are optimized and they don't have to keep hunting for extra compute. Let me walk you through an animation of how this actually works, and then I will jump into an actual demo. So imagine that there is an organization that has a shared cluster, shared HyperPod cluster across all teams. The admin does a dynamic allocation. What does that mean? He says, team 1, you have been granted a quota that you can use up to 100 P5 instances. Team 2, you have been granted quota that you can use up to 50 P4 instances. So this is dynamic allocation. You have been allocated a quota. I have not given this compute to you and told you that this is your compute, but I have given you the quota that you can use from that shared cluster. Second, I as an admin can define some governance policies on the cluster, and those are, first is the task prioritization policies, which says that what is my highest priority task, second type, third type. I can say inference is highest, training is next, and fine tuning is third, and data processing is fourth, whatever, right? At the same time, I can also say how can teams get if there is idle compute sitting. I can say that every team can have, all the teams get a fair share of idle compute. And this is very critical because you don't want one team to take over all the idle compute and other teams sitting idle. But instead, you can actually say that I have 5 teams. I want to make sure that every team gets a fair share. And by definition, this does not mean that every team gets 20% of the idle compute because there are 5 teams. It actually means that it depends on the priority of the team. It depends on how much idle compute has a team already utilized beyond their allocated quota. And it also depends on how much of idle compute they need. So that's where the fair share comes. So that not one team just gets everything, or it's not always like it's an equal division. It's actually based really on a fair share algorithm that happens behind the scene. Now let's see an actual working here. So imagine that whenever we create these teams, or whenever admin creates these teams, and we are using the open source queue behind this. So each team gets their own namespace in the queue, and those teams also get their own cluster queues. These are the local queues, because when they submit a task, the task first goes into the local queue, and then based on their allocations of the compute, or based on how much compute is required, that's when they are actually put into the cluster, allocated to the compute. So we have the setup done. We have done dynamic allocation. We have done the cluster policies. Team 1 submit task 1. They just need 1 GPU for the task. So they get guaranteed allocation compute because of they are within their quota. Second thing happens within their quota. Team 2 does task 3, and team 2 does task 4. At this point in time, everyone has their own guaranteed compute getting utilized. They don't have any wait times. They are able to use, but very interestingly, after this setup, you see that team 1 has an idle compute sitting. And it so happens that team 2 is submitting a task, but they have maxed out their allocated compute. So task governance kicks in and make sure that idle compute is used to submit this task. Now, let's complicate this even further. The same team submits a higher priority task now, T6. There is no compute available at this point. No idle compute available. What task governance does is, based on the cluster policies that you have defined up there, which is the task type prioritization policies, it preempts T5 back to the cluster queue, to the last checkpoint that you had enabled, submits T6 into that. And now, let's say team 1 comes back to submit T7. It needs it idle. Till now, it has been lending its idle compute to someone else, and the other team has been borrowing the compute. But team 1 is back and telling that, guys, I'm back. I have submitted my task. I need my compute that was allocated to me. That's where you go back to your guaranteed allocated compute. The task that was running on the borrowed compute is again preempted. It waits for idle compute to be available, and this team gets back its own compute where this task is executed. All of this admin can monitor real time in the dashboards. So let me just do a quick demo to show you that. So Amazon SageMaker HyperPod task governance, its capabilities are available in SageMaker console, SageMaker AI console. And as you can see, we have this runs on SageMaker HyperPod clusters orchestrated by EKS. So once you go to your EKS cluster or on HyperPod and go to one particular cluster, you will see 3 dashboards, 3 tabs: dashboard, tasks, and policies. Dashboard is where you get your real-time metrics. Tasks is where you can see tasks that are running on the cluster submitted by those teams and the status of those tasks. They could be running, they could be waiting, they could be preempted. And policies is where you define the 2 policies that I talked about, which is where I do allocations. I can define how idle compute is used by teams. I can define the task prioritization. So right now, this particular cluster has nothing running. It's good. Utilization is low. Fine. Right? You don't have any utilization going on. The top section shows you the utilization, the cluster utilization metric. Sorry, the cluster health metrics. Now let me go to the policies itself. Okay. Let me take a pause here, and this is where you define the two types of policies. The first policy is the task prioritization policy, and you can define your classes. You can say that my inference has a weight of 15, training has a weight of 10, fine tuning has a weight of 5. What this means is on the cluster, if there are tasks that are contending for resources, inference will be given the highest priority for the resources. I can also say, if you see underneath that, it says idle compute allocation, fair share. I can either say that please give idle compute based on first come first serve, or please do it on fair share. When you do it on fair share, then based on teams and their weights equals to priority of the team, and how much of tasks they have waiting, type of tasks, how much have they already been utilizing idle compute, they will be able to use the idle compute itself. And this is where I define my allocations. For this particular demo, I have simulated 3 teams. One team that works on a chatbot, one team is a bunch of researchers, and one team is a bunch of engineers. And you can see the fair share that I've allocated to them. I'm telling that my chatbot team has a weight of 100, the other team has 75, and the third team is 50. So this comes into picture when teams try to contend for the idle compute itself. Now, you can also see which instance type they have a quota on, and you can also see the last in the all the way at the right, what is their compute sharing strategy. The first team, chatbot, is actually doesn't want to lend its idle compute to any team. It has its own reasons for doing it. But the other teams are okay to lend and borrow idle compute. So I just went into one particular team's details, allocation details, and I see that that particular team has ML, G5, 8x large nodes, 6 of those allocated to them. So what has happened is, of the entire cluster that is available in this organization, this team has been allocated a quota of up to 6 of these instances. It's not that they got the 6 instances, they have been allocated a quota of up to 6. And this team is also allowed to lend and borrow compute. What that means is that this team can lend idle compute if it has idle compute from its quota, and it can also borrow if it has already used a policy compute. How much can you allow them to lend? Because end of the day, they also have some cost implications. They can borrow up to 50%. Is up to 50% over their allocated compute, is what we are telling for this particular team. So now that I have set up this everything, let me show you the task tab. Right now there are no tasks running, and you also saw that in the metrics dashboard, right? The utilization was all 0. There are no tasks running. We have created our setup. We have defined the teams. We have done the allocations and everything. No tasks running. So now the ML engineers team is going to submit a Llama job on this particular thing. And very interestingly, I want to show you something here. Is one of their asks is, this particular team needs 8 instances to run this job. How much were they allocated? If you remember, they were allocated 6 instances. But to run this job, they need 8 instances. They went ahead and submitted the job. And when we refresh it, you will see that this job is running. and it is using 8 GPUs right there. But it was only allocated 6 GPUs. Now in the dashboard, you will start to see the utilization lighting up because the job is running. This is the cluster utilization metrics. You can see that that particular utilization has gone up in the time series. But here, interestingly, this is the governance metrics. We had 3 teams. You see their allocations 4, 5, 6, but ML engineers team is utilizing 8, so they are borrowing 2, and they are borrowing 2 from the team that was okay to lend their compute, which is research team. So they are borrowing 2 compute from the research team. And this particular view gives you a clear idea of how much every team, the blue bars are how much is the allocation, because your y-axis is the allocation of is the count of GPUs, how much is the allocation, and the line shows the utilization. The 2 teams, if I were to move my mouse, the 2 teams on the left are not utilizing anything. That's why they are 0. But the third team, ML engineers team, is actually utilizing more than their allocated compute. That's why you see their allocation point. And this gives you a real-time, quick input on how the team is actually utilizing their allocations. Now I'm just going to speed up a bit. I want to show you that the research team has come back and is going to submit a task. Now the research team is actually lending 2 of its GPUs to the other team, if you remember. But now the research team is going to submit a task on their own. And now when they did that, first thing is, the task that was submitted by ML engineers team got suspended. It got preempted because it was borrowing someone else's compute that needed the compute back. And you can see that the research job is now running and utilizing that compute. In the team metrics, real time, you can see that the research team has 1 running task, but the ML engineers team has 1 task pending because it got preempted. And so with that, what we get to see is, we get to see that how different teams can be given tasks, and this is a very short demo, but how different teams can be given allocations, how they can burst into idle compute, how they can preempt other teams' tasks borrowing their compute, and how prioritization happens. With this, I want to actually invite my friend from Articulate to be able to talk about how they are using this in their actual real-world scenario.
Thank you, Kareem. Really appreciate it. Can everybody hear me okay? Just give me a thumbs up. Awesome. And if I'm speaking too loudly, just give me a thumbs down. If you happen to have rotten tomatoes in your pocket, throw them on stage. We'll figure it out. But thank you all for being here. And thanks again, Kareem, appreciate the invitation. So my name is Shyam Kumar, and I'm from a company called Articulate AI. Arun Subramaniam, he's our CEO. If you guys came here specifically to see him talk, sorry to disappoint you. You're dealing with me today. But I lead our commercial operations. I'm part of the founding team at Articulate. And what we do is we have developed a full stack generative AI platform, not unlike Bedrock, but I'll get into some of the details. And we were launched officially in January of this year, but we were building this in stealth mode for about 2 years. The entire founding team is ex-AWS, so we know our friends at AWS really well. And some of the things we do differently is, let me hone in on one thing to start with. So in our view of the world, when it comes to Gen AI and large language models and so on, we do not believe one model is good at solving all tasks for every industries. Our design philosophy from day one was it's going to be a collection of models, both LLMs and non-LLMs working together at scale. That is going to give you the best outcomes for any enterprise application. And The second thing we are doing, and to actually address that, we've developed a technology we like to call model mesh. Model mesh has a collection of models. Out of the box, we provide 20, 30 different models. These, of course, include LLMs. But we've also fine-tuned and done some continued pre-training on models for specific tasks that are broad, but also specific tasks that are industry-specific and domain-specific. We have a number of data partnerships in aerospace and semiconductors, financial services, and so on. And we believe those models are going to give you best-in-class price performance for specific industries. So that's a domain-specific model approach, and the model mesh as well. Even though we've only been in business for about 11 months, we are a mature team. You can see all my gray hair here. And so we have a number of customers already in various stages of production deployment when it comes to GenAI applications. And everything in our platform is self-contained, pre-packaged. As you all know by now, you need typically 20, 30 different technical components that need to go together to create any kind of enterprise-grade, production-ready GenAI application. And doing it at scale is a challenge. Easy to do POCs and experiments. Going to full-scale production is a challenge. So we put all of those pieces together. And how does it help you? It actually accelerates your outcomes, time to outcomes. So you can deploy something using Articulate within weeks, which is production grade from day one, as opposed to months if you build it yourself. And the entire platform sits in your own secure environment within your AWS VPC. So we like to say we're bringing the GenAI technology to where the data resides. No data ever leaves the customer environment in our case. Everything is self-contained. We are not a wrapper company around OpenAI or everything. All the models we provide comes with the platform, sits in your environment. So we take care of security. We have taken care of scale and production-grade systems. And our business model is also differentiated. I'll actually get into that later. I'm not here to sell Articulate today. I want to actually tell you more about how we are using HyperPod to accelerate our own journey. So until now, since ChatGPT was announced, what was it, about roughly 2 years ago, back in November, just last month, there's been a lot of noise in the system, as all of us know, a lot of hype around GenAI. And until now, the worldview has been there's going to be this one large model which has very broad general knowledge. It can do everything you want, and that's the model you're going to deploy in production. That worldview is already changing. We are hearing from our customers that you're going from these general knowledge models to domain-specific models that can solve their specific use cases and problems in domains like aerospace, like semiconductors, like automotive, and oil and gas, and so on. So we at Articulate, from day one, have been focused on putting together data partnerships to build out those domain-specific models. And if you go 5, 6 levels deep in any domain, let's just say aerospace, which is my background, you want to do something related to composites design, or you want to do something on aeroelasticity or computational fluid dynamics, yes, ChatGPT, Anthropic can answer some questions. But if you go 5, 6 levels deep, that's going to break down. So you will need, at some point, models that understand domains very deeply. Just to mention a few things, image understanding of aerospace-specific images, equations specific to computational fluid dynamics, structural mechanics, and so on. That is challenging, and that's what we're doing with our domain-specific models. But we don't believe that's sufficient, because if everybody's using the same general knowledge models, and if everybody's using the same domain-specific models, you're all getting the same uplift in productivity and accuracy and performance. How do you differentiate yourselves from your competitors? So the next step, we believe, is customers using domain-specific models, putting it in their own environment, and then fine-tuning those models further using their own data. That is going to truly give you the differentiation compared to your competitors. So that journey is what we are helping customers take along with our platform. And so we have a platform that's highly abstracted. We don't provide model APIs. We provide platform APIs. And those platform APIs, you can do, of course, broad general purpose tasks like Q&A, summarization, chat, and so on. But we also provide fine-tuning APIs that you can use to fine-tune your own models. Because the entire platform sits in your environment, any model you fine-tune using your data, that's yours. That's your IP. That never leaves your environment. So why is this important, right? And how does HyperPod come into play? In our view of the world, we are going, and this journey is just starting, we're going from a world of 1, 2 large models to a world where we believe there's going to be hundreds and thousands of models. And not necessarily smaller models, it's just the nature of the business that these could be smaller. But if you go to these hundreds and thousands of models, you're going to require some system to fine-tune repeatedly models doing different tasks. And these could be broad tasks, but we believe these are also going to be domain-specific tasks. Again, going back to an aerospace example, a model that you might use and the tools you might use and the data you might use in early stage conceptual design is going to be very different from what you would do in manufacturing of, let's say, composites or something like that. So we believe there's going to be fine-tuned models in every domain, so hundreds and thousands of these. And this is really where HyperPod comes into the picture. And so our applied science team, data science team, research team, I'm not a data scientist myself, that team's grown into tens of people now. And the challenge we were having is a lot of these data scientists acting as IT folks, not the best use of their time, setting up their own clusters for high-performance computing. And 24/7, we are constantly fine-tuning, creating new models, evaluating new models. And this was starting to become a drag on our team. So we needed a better solution that could automate some of these processes for us. So things like, I think Kareem talked about this, Joy talked about this as well. How do you actually use one of the most precious resources any AI company or any company that's doing AI, how can you better utilize GPU resources, one of the most precious resources you can have today? You do that by addressing any kinds of interruptions in an automated fashion. For example, if a node goes down, you don't want your data scientists figuring out how to replace that node or go and heal that node. You want to do it in an automated fashion. So we were evaluating a number of tools. By the way, I come from the world of high-performance computing going back decades. I don't know if any of you know SGE and LSF and PBS and some of those job scheduling tools. If you don't, it's okay. But that's the world I came from, so this world's changed quite a bit. But yeah, how do you handle these interruptions? How do you allocate resources between different heterogeneous compute sources, but also between different projects and different teams and so on? And how do you do it in an automated fashion, and how do you do it at scale? That was the challenge we were facing. And HyperPod actually addresses this really well. How do you prioritize between a domain model that we're building for aerospace versus semiconductors versus customers asking us to help them fine-tune their own models in some cases? They don't want to do it, they want us to do it. How do you prioritize all these things? And again, HyperPod to the rescue. And then, of course, cost management and optimization, right? When you're dealing with GPUs, as a startup, 60%, 70% of our burn rate is just GPU consumption. It's crazy. How do you manage and optimize those costs? And I'm sure this is important for everybody. And again, you need some kind of automated tool that can do this at scale and do it well. And I'm not going to go into a lot of detail. I don't know how much time we have, Kareem, but we will be available to talk to you right after this talk. Kareem's here, I'll be here. We have Alex here sitting in front as well. Happy to answer any technical questions you might have. But again, when it comes to tracking, first of all, to optimize, you need to be able to measure. And how do you measure and track using a single pane of glass? And this is what HyperPod does for you really, really well. And allocation between GPU resources, tracking GPU utilization, tracking memory utilization, CPU versus GPU, because a lot of the, example, data ingestion tasks don't necessarily require GPUs. You're doing that through CPUs. And how do you manage all of those in an efficient and optimized manner? And that's something our team's really doing using HyperPod today. And task governance has been like a huge help. Same thing with resource allocation. I'm not going to, again, get into details, but HyperPod task governance actually has some really cool, I would say, very granular knobs that you can tweak to manage all of this really efficiently. And prioritization of tasks, we already talked about that. And you want to also hold your teams accountable and yourself accountable. If you're allocating resources, you have some expectations set on how these resources are being utilized. You want some measure of that as well to trace back, see what's working, what's not working, adjust your strategy, and so on. And that's where, again, HyperPods come into play. And in the interest of time, I'm just going to continue on here. And I want to say this. So I mentioned before, our entire platform sits in the customer's own environment. That is true for our enterprise product and our expert product. But as a commercial guy, a business guy, I actually challenged our team a couple of months ago to create a new product. And this is actually a SaaS product called Articulate Essential, A8 Essential. And we wanted to do this in a very compressed time frame, 2 to 3 months. This is actually launching in January. We only started talking about this a couple of months ago. And part of this, it's actually going to include that collection of models I was mentioning. We are building new models that we want to be part of A8 Essential. And with a very aggressive time to outcome timeline, we were challenging our team to do this. We could not have done this, and we cannot do this without actually using HyperPod, especially task governance. It's really helped us a lot in fine-tuning new models that are going to be part of this entire system. The reason we did this, by the way, is people were saying, great, we can install your enterprise product, but it's going to take us a few weeks to do that. We want to see something proof of value really quickly. Can you show us something within days? So instead of giving them a sandbox environment, we actually created a product. And at the moment, it's a free product. And you can actually go sign up to start using this and ingest your documents, for example, just as an example, and start testing this product come January. So if you're interested, please reach out to us. Happy to show you how this works. And we don't believe this is going to be the revenue driver for us, but it's a great starting point to test how our platform works. Eventually, we believe it will be actually deployed in the customer's own environment. So again, we could not have done this without HyperPod for sure. And just to close this out, I'm going to pass it back to Kareem. And we are here to answer any questions.
Thank you, Shyam. So yeah, you saw Articulate's story, how they were able to use HyperPod and task governance to actually come up with a product in 2 months, which they're going to launch in January. So congrats to them and wish them all the best. So now to just conclude and bring back everything into a quick a slide here is, so what we have launched. We have launched Amazon SageMaker HyperPod Task Governance. It enables you to maximize the utilization of your accelerators, at the same time reducing the costs. And it's for any type of tasks, your model training, your inferences, your fine-tuning. And the key takeaways for you guys is that it enables you to dynamically allocate compute resources to your teams. It makes sure that high priority tasks are submitted before low priority when there is resource contention. You get real-time monitoring of your compute. And how the teams are being allocated, what is their utilization, how much of the tasks are waiting, how much are they bursting over, how much are they underusing. And at the end of the day, it grows the utilization of your resources by reducing the cost by up to 40%. Here is a quick set of all the QR codes that you can take a picture. We have a blog that helps you walk through these use cases. Our web page is updated with a lot more literature, and this is the documentation in case you want to take a quick pic of this. And yeah, thank you.